Hello, Soham. Good evening. So actually, I was waiting for others to join. That's why I have not started. Others will not be joining. Have you have any idea?
So Amitesh will join. I think a little later. I'll just force him my system.
Yeah, please ask him if he is joining within 1 or 2 minutes. Then we can start along with him. That's why I was waiting. Okay, so we can start. Let him join. So can you tell me in last class what we have done? And I think I have given some homework to you. Soham, can you hear me? Some of the compounds.
So I got cut off. So can you repeat what you said?
I am telling, let him join so we can start. And I'm like remembering I have given some homework to you. That homework we will be discussing that I put something like that. But some compounds I have given to find the hybridization and the geometry and shape that we have to discuss today. Can you see in notes what we were discussing at last?
So we were doing Z is equal to 4. The structure for that.
So okay, so I told the formula of Z to find the particular Z value and the hybridization and corresponding shape and geometry that I was discussing.
Yes, sir.
Okay. Can you tell the last mm, last I mean to say subtopic what we were discussing? This you told the topic, okay?
So we did the structure for lone pair is 2, one pair is 2, and the
Yeah,
geometry
yeah,
shape and hybridization for that.
yeah. So yeah, I now I remember. So like a different stick number I was taking, then under that sub cases we were taking that if we are increasing number of lone pair, then what different shapes we can get up for particular geometry. Okay. So streak number two done. I think streak number two we have done.
Yes.
Okay, so we have to start with streak number three. Streak number three done or not? On the streak.
No, sir, I don't think so.
Okay. Two done, na? Two. Are you sure? Two. with one lone pair linear geometry.
Yes, sir. Yes, sir. We're done with three also. We start with four.
Yeah, yeah. So that only I was remembering. The three I have told you that with one lone pair it will be bent shape, and I've shown the structure also with one lone pair. Okay, so we can start with fourth one.
Yes, sir.
Okay, fine. So let me share my screen. Okay, so screen visible. Okay, so now we will be discussing like four. So again, we have to make table Z value, bond pair, lone pair. Then we are having geometry. Then we are having shape. Then we are having hybridization. So starting the Z value 4. So now first we'll be taking like the entire four stick number to be four of bond pair only. Lone pair you are having zero. So I told that geometry and shape is same when lone pair is zero. So here also geometry will be tetrahedral. Shape will be also tetrahedral. And your hybridization will be sp3. Now we'll be increasing lone pair one at a time. So 4z here, sorry, here it will be 3 now. Lone pair will be 1. So geometry is tetrahedral. And with one lone pair, it will be looking like this one. A is bonded with B. And here you are having lone pair. So with one lone pair, the shape will be pyramidal. And your hybridization will be sp3. Now again, I increase lone pair one more. So bond pair will be 2 here. Lone pair will be 2. It will become tetrahedral. And since now we have to place out of the four, two lone pair. So this will be like this one. A is making bond with B. And two lone pair here. One here, one here. So hydrogen will be also sp3. Okay, so I'm giving one question. Please do this. You have to find lone pair, hybridization, geometry, shape. First compound I'm giving you CH4. Second is NH3. And third is H2O. Okay, so this is very easy question. 5 minutes I'm giving to you. Please solve it within 5 minutes. Okay, got? Tell, Suvan.
Yes.
Tell.
So the CH4 has zero lone pairs, four bond pairs. So I mean four sigma bonds. So the value is four. The geometry is tetrahedral and shape is also tetrahedral.
Very
NH3
good.
has one lone pair and it has three sigma bonds. So that is four. Geometry is tetrahedral and shape is pyramidal.
Very good.
H2O has two lone pairs and two sigma bonds. So that is four. And the geometry is tetrahedral and the shape is bent.
Okay, very good. So Z is 4, sp3, tetrahedral, and shape will be also same. That is tetrahedral because lone pair is 0 and bond pair is 4. So Z here 4, bond pair will be 3, so lone pair will be 1. And I have already told you this is geometry, this is shape. Geometry will be tetrahedral, shape will be pyramidal. Then H2O is also Z is equal to 4. Bond pair here you will be having 2, lone pair you will be having 2. Geometry and shape. So geometry will be tetrahedral and shape will be bent. Okay, very good. So now we will be moving to next one. So next we are going to take Z is equal to 5. Okay, so let draw this again. Z, then you are having bond pair, then you are having lone pair, then you are having geometry, shape, hybridization. So here in Z equal to 5, the case will be somewhat different because if you remember in last class I told you, because there is equatorial as well as axial. So from where you are putting lone pair, that will create different shape. All the valencies are not identical. Okay, so starting with when I'm taking lone pair 0, so bond pair will be 5. The geometry will be TBP, that is trigonal by pyramidal. Shape and geometry are same when lone pair is equal to 0. So this will be also TVP and hybridization will be SP3D. Next, I'm increasing one lone pair. So 5, bond pair are 4, lone pair will be 1. Okay, so here what happens like lone pair will be always going in equatorial. They will never go on axial plane. Okay, do you know this thing that if percentage S character increases, electronegativity increases? This point do you know?
Yes, sir.
Okay, fine. So what happens like if I draw TBP, so there are three bonds like this equatorial and two bonds axial. So this is equivalent to sp2 because three bonds are 120 degree apart. So if I divide this sp3d, so I can divide this sp3d into sp2 plus pd. So axial one is pd and this equatorial one is sp2. So can you tell me out of this equatorial and axial, which one is having higher electronegativity?
Sir, axial.
No, here I told you hybridization of equatorial is sp2 because they are at 120 degree apart. And the axial which are above the plane or below the plane, their hybridization is pd. So out of sp2 and pd, which will have higher electronegativity that I am asking?
Also, then equatorial.
Because percentage character is higher, no there. Understood or not? Okay,
Yes.
let me draw this clear here. So this will be SP2, and the one which is above and below the plane, that will be PD. So it is high EN. Percentage S is high. Okay, so now can you tell me, if I am putting lone pair, one lone pair, where it will go? Axial or equatorial? Hmm? Tell.
So axial.
What logic you have applied?
So I don't actually know.
See, if you are putting lone pair, so lone pair, at which position they will go? Where En is higher or where En is lower? Hmm? Tell this one. There are two positions. One is having high electronegativity, one is having low electronegativity. So where lone pair will go?
So towards high alternately.
So at which position we are having high electronegativity?
Equatorial.
So lone pair will go at which position?
Equatorial.
Understood, no?
Yeah. No, so I didn't get how equatorial has high electronegativity.
I told the hybridization, no? What is the hybridization of equatorial?
SP2.
And for axial?
PD.
PD. So I asked you, no, you know that if percentage S character is higher, En is higher.
Yes.
So percentage S character is higher in which? SP2 or PD?
SP2.
So that's why. Okay, understood? Okay, so now we can write this one. 5, sorry. Here it will come 4. Here it will come 1. So now if you are putting lone pair, it will be looking like this one. In equatorial, one of the lone pair you put like this one, and the other two will be axial. So it will be looking like this one. Okay, so let me make this here. So geometry will be TVP, but can you tell what will be the shape? Amitesh, can you hear me? Soham?
No, so I don't have any idea how the shape would be.
See, it is looking like in playground, you have seen one type of game is like that one, that two-person can sit opposite to each other and they can balance. Like if one is going down, the another one will go up. Have you seen that type of?
It's a seesaw.
Yeah. So it is looking like the same that one. If you see it like this, no, if you rotate it by 90 degree, so are you able to see like this one? So this is having the same shape like that. That's why its name is seesaw. Amitesh, can you hear me? You are attending or not?
Yes, sir.
Why you are late? Why you have not joined on time?
Sir,
Last
like I have a tuition and it ends like 6:30 and it takes time for me to come from there to here.
and last class also you left half an hour early, I think.
Yes, sir.
So have you watched that recording?
Sir, I think I have. Sir, I'm almost done with the recording. I'm only the last 5 minutes I could watch.
Okay, no issue. So here you understood that why we are placing lone pair in equatorial, not axial.
Sir, could you repeat?
I am telling in TPP geometry, there are two types of bond. No? One is equatorial, that is along the plane 120 degree, and two valency are up and down. So the one which is in 120 degree plane, that is equatorial. And the one which is up and down, they are axial. So do you have you understood this, that why I have put lone pair in equatorial but not in axial? Hmm? Tell
Sir, no.
why? Okay, this you were listening that I told that equatorial and axial, you understood or not? Equatorial and axial. What is equatorial? What is axial?
Yes, sir.
So this I was telling that equatorial hybridization will be sp2. Means sp3d can be written as sp2 plus pd.
Hmm.
So sp2 is the hybridization of that three valency in one plane. That is equatorial. Because your sp2 is also looking like that one, 120 degree apart. So equatorial hybridization is sp2, axial hybridization is pd. And if percentage S character is higher, electronegativity is higher. This you know beforehand.
Oh, yes, sir. Yes, sir.
So that's why which will be having more electronegativity, equatorial or axial.
Sir, equatorial?
Okay. Now when we are putting lone pair, so lone pair are electrons. So one the atom which is having more electronegativity, that will attract it.
Oh, yes, sir. Yes,
So
sir.
that's why lone pair it is going in equatorial, not axial. Okay. So
Yes, sir.
this is the these are the minute concept that I am telling you. Means if you it is not clear, then you will be getting doubt afterwards when you will be realizing that why I have put lone pair in equatorial, why not in axial. That's fine. Okay. So next case we can take. So again we have to like this one Z bond pair, lone pair, geometry, shape, hybridization. So Z again 5, lone pair I will increase to 2, 3 bond pair. So geometry will be TVP only, but now shape it will be like this one. Two lone pairs will be there and one bond. So in that equatorial, I can place two lone pair like this one. And one bond I can place like this one. And the other two axial will be like this one. Okay, so can you tell me the shape of this geometry? Hmm? Tell. See, in shape, we do not count lone pair. So you can hide lone pair. And the rest, what you can see that actually will be the name of the shape. So what will be the shape of this one? Can you tell? It is very easy.
Sir, pyramidal.
I am telling that two lone pairs I have kept, and the two lone pairs will be kept in equatorial position. The third will be bond, and the other two bond I have made axial. So for shape, I do not take lone pair into account, or I only see bond pair. So according to bond pair, what is the shape of this?
Sir, bipyramidal.
How bipyramidal? How it is looking like bipyramidal?
Oh no, sir.
Can you see any alphabet letter that is being formed? Hmm? Tell Soham. Can you hear me?
So I feel it's pyramidal, but I don't know.
Pyramidal, why pyramidal? Why you are telling pyramidal? Pyramidal is like having lone pair above, then all the valency downward. That is pyramidal. So I am telling that if you rotate the compound by 90 degree, 180 degree, can you see any letter that is being formed? Any alphabet letter that is being formed?
T.
Yeah, so that's why its name is T-shaped. Okay, shape is T-shaped. So hybridization is sp3d. Okay, so next we are going to increase one more lone pair. So geometry will be TBP. Now here three lone pairs you have to keep. So one here, and one here. The other two valencies are this axial. Okay, now can you tell me what is be the shape of this one? Hmm?
So linear.
Yeah, very good. So you can see like lone pair we do not count. We see only bond. So bond are kept in linear fashion. So hybridization is sp3d and it is linear. Okay, so now based on this, I'm giving some question. Please solve this. So what you have to do? You have to find that only. Find what? Lone pair, hybridization, geometry, shape. The compounds are, first I have given ZeO3 F2, second ZeF2, third ZeO F2. Okay, so please solve these three. I am giving you how much? 5 minutes. Okay, done. Amitesh,
Sir, 3 minutes.
Soham, Saket, can you hear me?
Yes, sir.
So why you were absent in last class and previous classes?
Sir, I had gone out. I was not at home. So,
So have you gone through recording? Have you watched recording?
no, sir, not yet. I came back last night, sir.
Okay, so please watch recording. Then only you will be coming to know. Then only you will be understanding. No, otherwise, how will you come to know that what we are discussing? So please watch recording. And if you have any doubt, please tell me in next class so I can tell you
Okay.
whatever concept you miss and how you can solve that one. Okay, understood.
Okay, sir.
Okay, Mitesh, tell. Soham.
Sir, I'm
Yes,
still
sir.
doing.
Okay, take 2 more minutes. Do then we can discuss. Okay, done.
Yes, sir.
Tell.
So the first one is zero lone pairs. There are five
Hmm,
sigma ones, so that is five. The geometry is trigonal bipyramidal, and the shape is also trigonal bipyramidal.
very good. Then JDF2.
So there are three lone pairs, two sigma bonds, so that is five. Geometry is trigonal bipyramidal, and the shape is linear.
Hmm. And last
And
one.
third one, there are two lone pairs and three sigma bonds, so that is five. The geometry is trigonal bipyramidal, and it is T-shaped.
Very good. Okay, so how to, okay, so let others please listen what I'm telling you. Here you have to see total number of sigma bonds and then total number of lone pairs. So Xenon, you already know, it is having 8 electron and it will be making double bond with oxygen. So 2 electron per atom of oxygen will be taking. So 6 electron gone with oxygen. Now left are 2 electrons, and that 2 electrons will be taken 1 sigma bond by fluorine. So all the 8 electrons are actually exhausted in making bond. That's why there is no bond, there are no lone pair. So bond pair we only count sigma bonds, no pi bond. So there are 5 bond pair, and lone pair you are having 0. So for 5 bond pair, Z is equal to 5, sp3d. Geometry I have already told you that it will be always TVP. And if I talk about shape, geometry and shape are same if you are having 0 lone pair, because only by hiding lone pair you create difference in making geometry. So ZeF2 again. So out of 8 electrons, there are only 2 sigma bonds made with 1 electron shared with fluorine. 6 electrons are left. Nobody bonded with that 6 electron. That's why lone pair will be 3 here, bond pair will be 2 here, and Z will become 5. So now geometry will be TVP here. But if I talk about shape, so 3 lone pair, I have already told you the lone pair goes in equatorial. So it goes like this one. The another 2 you are having like this one. So shape is linear. Now ZeOF2. So again 8 electrons. 2 electrons gone with oxygen double bond, and 2 electrons gone with single bond fluorine. So 4 electrons gone. 4 electrons are remaining as lone pair. So lone pair will be 2. Bond pair you are having 3. Z is 5. Geometry is TVP. So 2 lone pair you can keep like this one. And third is bond pair. So you can see shape you are getting T-shaped. Okay, so now next one, Z is equal to 6. So again Z here, bond pair, lone pair, geometry, shape, and hybridization. So Z you can keep here 6. So first I am taking 0 lone pair. So can you tell with 6 what was the geometry? So Amitesh. What was the geometry with Z is equal to 6?
So octahedral.
Very good. So geometry will be octahedral. And since no lone pair, so shape will be also octahedral. Hybridization will be sp3d2. Okay. So octahedral looks like this one. 4 valency like this one at 90 degree each, and two valencies are up and down. Now if I increase one lone pair, so lone pair increased by 1, bond pair will be 5, Z is 6. So geometry here will be also octahedral, no issue. But can you tell its shape? It will be like this one. See, 4 are there already. But upper valency you have to keep lone pair, and below valency will be like this one. So can you tell what will be its name of shape? Option will be sp3d2. Tell its name. so on.
So I don't know.
So this will be pyramidal. Pyramidal has like this structure. You have lone pair at top and all other valencies are at below. So it looks like pyramid from up. And since it is square present here, so name will be square pyramidal. Now next we can take, so again Z, bond pair, lone pair, geometry, shape hybridization. So Z you can take again 6. Lone pair previously was 1, so here 2. Bond pair will be 4. So geometry will be again octahedral. Shape you can see like there will be 4 valency like this, and 2 lone pair you have to keep. So 1 lone pair above, 1 lone pair below. So what is the shape name? Can you tell? Hmm? See, you can see the lone pair are above and below, and lone pair is not counted in shape. So entire 4 valency is present only one plane. So that's why the shape will become square planar. Square planar. So you can see it is square and it is present in one plane only. Okay, so now you have to tell me.
Sir, once again, could you go back to
So
the
let me
previous?
go back again, write it down. Yes, so done.
So find lone pair, hybridization, geometry, shape for XEF4. Okay, take 3-4 minutes and then tell me. Okay, done. It is easy, very.
Yes, sir.
Tell how you have done.
So XCF4 has 4 bonds, 2 lone pairs. So that is 6, and the geometry is octahedral and the shape is square planar.
Very good. Okay, so let me tell. So here I have told the last one like we have done. So xenon has 8 electrons. 4 electrons are lost in making sigma bond. So 4 electrons are remaining with no bond. So lone pair will be 2. Bond pair is 4. So Z value is 6. sp3d2. Now with 4 bond pair and 2 lone pair, geometry will be octahedral only. But shape, since lone pair will not count in shape, the only 4 valency will be in one plane. So that will be square planar. Okay. Okay, so now last one, that is Z bond pair lone pair hybridization. No, hybridization you can keep in last. Geometry shape hybridization. Geometry shape hybridization. Z last one is 7. Lone pair we take 0. Bond pair 7. Geometry is pentagonal bipyramidal. Pentagonal bipyramidal. And since lone pair taken 0, so here also shape will be pentagonal bipyramidal. Hybridization will be sp3d3. So it looks like this one. You have 5 valency at one plane. Okay. And 2 valencies up and down of the plane. So it is looking like this one. So you can see pentagonal is formed and 2 valency up and down. So pentagonal bipyramidal. However, it is not so important. Okay, just for coverage purpose I am doing. So all the cases we have taken, all sub cases also we have taken. So this VSEPR theory is very important. So I have covered this very thoroughly. I have taken each and every example. I've given practice to you also. Okay, so please go through it thoroughly. Every year questions are coming on this area, that what will be the shape with different lone pair and what will be the hybridization. So now a special point for DBP I would like to cover. So some part I have already told you that it is having 2 parts, equatorial and axial. So equatorial is sp2, 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 because they are 120-degree apart. And then you are having PD and PD. So sp3d is sp2 plus PD. This is known as equatorial. This is known as axial. Equatorial position is at higher En due to more percentage S. Okay, so this I have already explained you that here sp2, here no S. That's why equatorial position is at higher electronegativity due to more percentages. So whenever lone pair is coming, so that lone pair will be attracted by more electronegativity position, that is equatorial. So first point is lone pair go to equatorial position. So first is with regard to lone pair. Now second point is with regard to more En atom, more electronegativity atom. So suppose there are two types of atom. One atom is having higher electronegativity, one atom is having lower electronegativity. So how then I will decide that which atom will go where? High electronegativity atom should go where? Equatorial or axial? Can you tell?
So equatorial,
Why?
is because that is more electronegative. So
But your atom is also electronegative, no? So lone pair was electrons. So of course electronegative atom will attract electron. But for electronegative atom, what logic will you give? Hmm? More electronegative atom will go where? Equatorial or axial? Okay, can you tell which position is in dire need of electronegativity out of equatorial and axial? Where importance of electronegativity is more? In equatorial or axial? Okay, so Soham, I was asking out of equatorial or axial, which position is in dire need of electronegativity? Which has more importance for electronegativity?
so axial.
Because there is no percentages. So they are having deficiency of electronegativity. That's why electronegativity atom will go in axial. So this is one logic you can give. Another logic you can give, like in equatorial there is already electronegativity. So electronegativity will repel each other. So that's why it will not go in equatorial. More En atom will go on axial. So this is very important. Okay, this concept actually creates many doubts. Okay, so now based on these rules I have told, please draw structure for PCl3F2 and then tell me that how you have drawn a structure. Okay, so I'm giving you 3-4 minutes. You can draw in 3-4 minutes. Okay, drawn.
Yes.
So how you have drawn?
So PCl5, I mean, so PClF, Cl3F2, it is trigonal bipyramidal. Cl is an equatorial and F is an axial.
Okay. So now I am giving you PF3Cl2. So this you told like this one, no? So here Cl, here Cl, here Cl, here F, and here F. Like this you have drawn for PCl3F2.
Yes.
Okay, now draw for PF3Cl2. Okay, drawn. Amitesh, you will tell how you have drawn.
Sir, I'm still doing. Sir, 2 minutes.
Okay, take 1 minute, then tell. Okay, done this. Amitesh, tell how you have done. It is left. Okay, so you tell how you have done.
So I feel it's two F's in the axial position, one in
Hmm.
equatorial and CL in equatorial.
But why you have kept F in equatorial? It is
So
high
because
electronegative.
like no other place for it to like go. So
Very good. So here we have to go like this one. Okay, so if there is no, okay, Mitesh came in. Mitesh, can you tell how you have done?
Sir, I was not able to do this.
And the last one, PCl3F2.
Sir, the question is,
First I
oh,
have given
okay.
PCl3F2. So that's Soham told. Then I have
Oh,
changed
okay.
it to
Yes, sir.
to
PF3Cl2. Um,
uh,
sir, so, sir, how do I tell it?
you tell no equatorial in terms of equatorial in terms of axial. Which position is having how many atoms? Which type of atoms? You can tell like that one.
Yes, sir. So, sir, equatorial, it's fluorine.
Hmm.
Axial, it's 2 fluorine.
Axial is 2 fluorine, and equatorial.
Equatorial,
Uh,
sir, 1 fluorine and 2 chlorine.
so why you have kept like this one? What is the logic behind that one?
Sir, I didn't know how to do it. I just guessed.
No, so I have told you, no, this in last slide I have told you that if more En atom you have to take, that will go on axial position because in axial position there is less electronegativity. So out of fluorine, chlorine, which has more electronegativity?
Sir, both are equally electronegative.
No, only one of them can have high. No, how they can have same? They are
Sir,
different atoms.
is it fluorine?
Yeah, it will be fluorine. Fluorine is having smaller size, so fluorine will have higher electronegativity. Both cannot have. Okay, so that's why high electronegative atom will go in axial. So there are two axial positions, so that will be taken by fluorine and fluorine. But since there are three fluorine atoms, only two you are able to keep in axial. The one is already left behind, so that you have to keep in equatorial. You do not have any choice. And the two other equatorial position will be taken by chlorine because this is less electronegative.
Oh, sir, this is not how my thing look like. I did a mistake.
Okay, so this will be the correct structure. Please make in your copy. In
Yes,
equatorial, you will be having one fluorine, two chlorine, and in axial, you will be having two fluorine. Okay,
yes.
so now VSEPR theory is over. Now we'll be moving next topic. Next topic, we have to see like how bond angle changes with hybridization, or you can say how bond angle is different for different hybridization. So there are certain rules for it. That rules I will be telling to you, and then with that rule you can easily make the priority order between. Okay, so you can put down the heading bond angle. So first rule for bond angle is hybridization of central atom. So first you quickly find the hybridization of central atom. So that hybridization can be sp3, sp2, and sp. So geometry I have already told you. For sp it is linear, for sp2 it is trigonal planar, for sp3 it is tetrahedral. So the bond angle will go like this one: sp, sp2, sp3. So sp you are having 180 degree, 120 degree, 109 degree, 5 minutes. So in this way you can decide the bond angle of central atom. The second point then you have to look for, if suppose hybridization is coming same of central atom. So you can write if hybridization of central atom is same, look for lone pairs. If number of lone pairs increases, bond angle decreases. Okay. If no, so what happens, like, lone pair lone pair repulsion is greater than lone pair bond pair, and it is less than bond pair. So if lone pair are increasing, more lone pair will come, more lone pair repulsion will be there, and bond length will come closer to each other. So bond angle decreases. So example, I can take like this one. If I take between ammonia, that is NH3, and I take water. So water, there are two lone pairs, oxygen, and nitrogen has one lone pair. So of course the repulsion will be higher in between these two lone pairs. So what will happen due to this higher repulsion? There will be more repulsion between bond pair and lone pair. Now, when there is more repulsion between bond pair and lone pair, this bond pair will come closer to each other, and bond angle will decrease due to repulsion. Bond angle will decrease due to repulsion. Understood this point? Any doubt in this? Now, third point, if hybridization, okay, so first I have taken hybridization geometry for bond angle. If hybridization is same, then I will look for lone pair. Lone pair repulsion more, bond angle decreases. Now, if hybridization is also same, lone pair is also same. So you can write if hybridization and lone pair hybridization lone pair both are same. So in that case, you have to look for two ways. First is when central atom is different, and means there are two atoms in any compound. One is central atom, one is surrounding atom. So if central atom is different, so surrounding atom will same. And here central atom is same, surrounding atom different. So central atom, so since central atom is different, so you have to check for central atom difference in electronegativity. Central atom difference electronegativity. So example, if suppose I take like this one, A and B, So surrounding atom is same, that is C and C. Here also C and C. And En of B is greater than A. If your En is greater for B than A, no, make it like this one. En of A is greater than B. A has more En than B. So if A is having more En, then lone pair will be near to A always, because it is having more electronegativity. And since B has less electronegativity, the lone pair will be away from B. So can you tell me in which case there will be more repulsion? In AC compound or BC compound? In which case repulsion will be more? Amitesh, can you tell?
Sir, BC?
Repulsion between this bond pair and bond pair, where bond pairs are close to each other. Lone pairs, if the bond pairs are close to each other, they will repel more. So
Yes, sir.
in which case they are more closer to each other.
Oh, sir, AC.
So here the repulsion will be more. So bond angle will be more. So you can say bond angle is directly proportional to En of central atom. So you have just have to see electronegativity central atom. The one which is having higher electronegativity central atom, bond angle will be higher. Now likewise I can see here central atom is same, surrounding atom different. So surrounding atom different En. So here also I'm taking one example. So here I can take central atom same and surrounding atom to be different. A to B, A to B, and here A to C, A to C. Now En of B is greater than C. So if En of B is greater than C, the bond pair will be more nearer to B. And here it will be more nearer to A, because C has less electronegativity. Now can you tell me in which case repulsion is more, in AB or AC? So I'm tell in which case repulsion is more.
So AC.
Yeah. So here you can see like bond angle. Here you can write repulsion increases here in AC. Bond angle increases. So here you can write bond angle is, oh, next you can write, don't write here. So here you can write bond angle is inversely related to electronegativity of side atom. Okay, so En is higher, bond angle will be less. En is lower, bond angle will be high. Okay, so now I'm giving you some question. Please solve that one. BeCl2, BCl3, CCl4, NO2 plus, NO2 minus, CH4, NH3, H2O. Okay, so I'm giving you by 8:15 I will start discussing. So please do up till that. Up till that. Okay, done. Who will explain? Hmm? Soham, you explain.
Yes, sir. So the first one, so CCl4, BCl3, and BeCl2. So C is most electronegative, B is next, and B is last. So the angle of C is most, the bond angle of C is largest, CCl4 is largest, then in BCl3, then BCl2.
So, but this you applied the third rule.
Yes.
The- But for third point, what I have told that you have to apply when you are having same hybridization and same number of lone pairs. That I told now. If you are having different hybridization, then which rule you have to apply? Have you first find the hybridization and lone pair?
And also said to do that.
So apply the in sequence. No, whatever rules I have told, apply in sequence. The first rule I have told that you go with hybridization. If there is change in hybridization, so different geometry, different bond angle. If hybridization is same, then look for lone pair. Then you see which lone pair is higher. Lone pair is higher, so bond angle will become less. If hybridization is also same, lone pair is also same. Then you have to move to that one that you are telling. No, electronegativity of central atom and side atom. Second one, how you have done?
So second one, since the hybridizations are same, then there's like one lone pair NO2 minus, and there's zero lone pairs NO2 plus.
How hybridization can be same of both NO2 plus and NO2 minus?
Yes, sir.
Hybridization is not same. You can apply that formula no that I've told no half V plus M minus C plus A. Do you remember that formula? Valence electrons plus negative charge or negative plus charge if there is charge plus side atom FnCO. If you apply that hybridization formula, you get different hybridization for NO2 minus and NO2 plus. And then last one, how you have done CH41? Tell last one.
So CH4, NH3, H2O have all sp3 hybridization,
Then
and CH4 has zero lone pairs, NH3
hmm,
is one lone pair, H2O has two lone pairs. So the
hmm.
bond angle in CH4 is largest, then NH3, and then H2O.
So this one you have done correct. So CH4 hybridization first you have to do hybridization. So sp3, sp3, sp3. So then you move to second point that lone pair. So lone pair here is 0. Here lone pair is 1. Here lone pair are 2. So I told that bond angle is inversely proportional to number of lone pair on central atom. So if lone pair is increasing, bond angle will decrease. So that's why it decreases like this one. Okay, so I'm giving again 5 minutes. Please solve for first two by rules, sequence. Okay, and correct whatever the mistake you have done. Okay, done. Who will tell? So,
Yes, sir. So BCl2 is sp hybridization, BCl3 is sp2, and CCl4 is sp3. So BCl2 has the largest bond angle, then BCl3 and CCl4.
so you have applied that formula that I have given you. How you have
Now,
done?
since I actually manually drew the structures because I don't remember the formula.
So just by looking at structure, by counting lone pair plus bond pair.
Yes, sir.
Okay, so there is no lone pair, all are bond pairs. That's why. Tell for NO2 plus and NO2 minus.
So NO2 plus has sp hybridization, NO2 minus has sp2 hybridization. So NO2 plus has a more bond angle than NO2 minus.
Okay, fine. Okay, so I'm telling with formula that I've given. So Z is equal to half, I've told. Valence electron for beryllium is 2. Yeah, is 2. Then there is no charge and there are 2 halogen atoms. So plus 2. So you are getting Z value 2. So this will be sp. Likewise here Z half. Valence electron for boron, it is 3. No charges, so no plus negative charge, no negative plus charge. So 3 halogen atoms are there. So 6 by 2, 3. So you're getting 3, so sp2 again. So CCl4, Z will be half. Valence electrons are 4. 4 are other atoms, no charges. So you are getting 4, that is sp3. So bond angle I have already told you, for sp it is 180 degree. So BCl2 will be higher. sp2 is 120 degree. So it is 180 degree, it is 120 degree, and it is 109 degree, 5 minutes. So it will be the least. Now here you can apply Z formula. Half. Valence electrons are 5. Then I've told if there is any negative charge, you have to subtract it. If there is a positive charge, you have to subtract it. No side atom, hydrogen, fluorine, chlorine, bromine. So read that one. So 4 by 2, 2 you are getting. This will be sp. Here Z half, valence electron 5. The negative charge you have to add. So plus 1, no side atom. So this you got 3. 3 means sp2. So sp has more bond angle than sp2. That's why L2 plus has bond angle higher. Okay, so we are wrapping up here. So in next class, we'll be taking examples based on side atom and central atom. Okay, thank you. If you have any doubt, you can ask me, otherwise you can leave.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Bye.